All right, guys. So today, what we're going to do is talk about the slope of non-proportional relationships. Um, let's see. Was thinking about just putting the homework check in the video, but I think what I'll do is I'll check the homework with you personally while the other group is working on that bill work. All right. So here we're going to talk about the slope of non-proportional relationships. Now, normally when we find slope of a proportional relationship, we can just take a y and divide it by an x, and it'll work out if we have an ordered pair. Okay. But that's if it's proportional. Non-proportional doesn't quite work like that. Okay, and I'm going to show you. All right, so it says, according to the notes, to find the slope of a non-proportional relationship represented in the table, find the change in y to the change in x. So that doesn't mean triangle y and triangle x. It actually means, a little triangle means change in. Okay, so change in y and change in x. To find the change in something, you just simply subtract. Okay, so if I want to find the change in my y's, I can just subtract my y's. If I want to find the change in my x's, I can subtract my x's. Now, I don't quite normally teach it this way. I'm going to show you how I teach how I teach you how to find the change in y with a change in x. I do use subtraction for just 2 points, but not a table. But let's go ahead and look. It says, determine if the relationship in the table is proportional and non-proportional. Then find the slope represented in each table. Okay, so determine if it's proportional. You just take y and divide it by an x, but you got to check each one of them. So like for this particular one, the first x and y is -4, -4. So I'm going to take my y of -4 and divide it by my x of -4. I get 1. And the second order pair, I'm not going to use the ones with the zeros. I'm going to take 8, 2, and take my y of 2 and divide it by an 8. If I simplify it, I get 1/4. Automatically, I can tell you that this is not proportional, okay? Because I'm not getting the same value every time. So with that being said, the question is, well, what do I do to figure out whether or not, what the slope is or what the unit rate is? Well, if it's not proportional, I highlighted in green that you're going to find the change in y over the change in x, and you all make sure you're taking notes. So this is what I do. I write down the formula to find the slope from a table, or the unit rate from a table, the change in y with the change in x. And I'll look at between any 2 points, and I'm going to choose these 2 points. That ordered pair and that ordered pair. And it doesn't matter which ordered pairs you choose. So I'm going to figure out, what do I do to -4 to get to a -2? So I don't necessarily subtract mine. I just figure out what I'm adding or subtracting to that -4 to get to -2. I'm adding a 2. And you always start off with your y first, because you got y in your numerator. It's always y before x, okay? So I'm adding to -4 plus 2 will give me that -2 here. So I know the change in y is plus 2. Now I have to find the change in x. So I have to say, well, what am I doing to -4 to get to a 0? Well, I'm adding 4. -4 plus 4 gets me a 0. So I'm adding 4. So I know my slope, or my change in y over my change in x, is 2/4. And if I simplify it, my slope is simply 1/2. Now, guys, it does not matter what 2 points you choose. You're still going to end up with a slope of 1/2. So I'm going to erase this. It's not the eraser. But make sure you do the change in y, not the change in x first. Okay, change in y first. And I'm going to choose 2 different points. So I could choose this point and that point. It doesn't matter. Just choose any 2 points you want to, any 2 ordered pairs you want to. So I'm going to find this change. So what am I doing to -2 to get to 4? Well, I know I'm increasing, so I'm adding. Well, what are you adding to -2 to get to 4? Well, you're adding a 6. So the change in y here is a plus 6. Then you have to find the change in x here. What are you doing at 0 to get to 12? Well, you're adding 12. So when you simplify, you still get 1/2. So again, I don't care what two ordered pairs you select from the table. Just select 2 and find the change in y versus the change in x. All right, let's take a look at B. B, I'm going to check to see if it's proportional. So I'm just going to take my x's and my y's and divide by my x's. So the first x and y is going to be 10 divided by negative 10. Puts me at negative 1. And of course, if I take 7 and divide it by negative 5, I do not get a negative 1. So again, this is not proportional. I'm not getting the same number. Okay, so now I need to resort back. And if I can't divide a y by x to get the unit rate / slope / rate of change, I must use the other formula, the change of y over the change of x. So all I'm going to do is simply choose 2 points. Doesn't matter which 2 you choose. Just choose 2, guys. So I'll choose something like, I don't want the comment. I don't know. I'm just going to highlight 2. Okay, it doesn't matter. You can highlight just 2 consecutive ones. It doesn't matter. Just choose 2. All right, so what am I doing to 7 to get to 1? Oh, I know I'm subtracting. So I'm subtracting what? I'm subtracting 6. 7 minus 6 gives me that 1. So the change here in the y's would be a negative 6. And what are you doing a negative 5 to get to a positive 5? Well, you know you're going up, so you're adding something. But negative 5 plus what would get you to a 5? Well, that would be a plus 10. So now all I have to do is make sure I simplify. Make sure you simplify your slopes, guys. You can divide them both by 2. So the slope here is negative 3 over 5. And that's all you do. All right, let's take a look at C. C, I'm just going to check to see if it's proportional. So I'm going to look at my ordered pairs and take my y's and divide them by my x's. So the first ordered pair is negative 3, negative 6. So I'm going to take the y of negative 6 and divide it by negative 3. It gives me 2. There's a 0, 0, which is another indication that it's proportional because it's going through the origin. But don't check the ones with zeros, okay? And then the second order pair that I have is 3, 6. Well, actually, it's the third, but it's the second one I'm going to check. So take your y of 6 and divide it by 3. I get 2. 4, 8. Take your y of 8 divided by 4. I also get 2. Take your y of 10 divided by 5. I also get 2. So automatically, I know that this is proportional. And m simply equals 2. My slope or my unit rate or my rate of change is 2. Now make sure you're pausing the video and taking notes, guys. All right, so now what I want to do is check to see if this other one will work. Because if that other formula will work on something like this, watch. I know for proportional, I can just take an x and a y and divide it by, take an x and y and divide y by x. But if I can just stick to using one formula instead of choosing whether it's proportional or non-proportional, I'd rather do that. So I can already tell you that on A and B, you cannot take just any y and divide it by an x. You must use the change of y and the change in x formula for A and B. But let's see on C if it works the other way around. If I can take y and divide it by x, if it's proportional, will this also work? Okay. We know over, again, on A and B, you can't take a y and divide it by an x, but the change of y over the change of x works. But when I can take a y and divide it by an x, will this also work? So let's check that on C. So on C, I'm going to pick 2 ordered pairs. I'm just going to pick the first 2 and see if this formula will work. The change of y over the change of x. So I'm going to ask, well, what am I doing on the y's to get from -6 to 0? Well, I know I'm going up, so I'm adding something. I'm adding a 6. So it's positive 6. And what am I doing to get from -3 to a 0? Well, I'm going up. What are you adding to -3? We're adding 3 to -3. So the change of y here is 3. And 6 divided by 3 is 2. Okay, so clearly this formula also works on the tables that are proportional. So this is what I'm getting at, guys. If this doesn't work for everything, it only works for proportional. This doesn't work for everything. It only works for proportional, right? But this works on proportional and non-proportional. So I say it's universal. So it works on both. This formula works on both. So instead of me trying to determine whether these tables are proportional or non-proportional, how about I just keep using the change of y over the change in x, because it works on proportional and non-proportional. So that's what I think I'm going to do, okay? That's what I suggest you do. Don't try to figure out whether it's proportional or non-proportional. Just use it for both. Just use the change of y over the change in x for any table. All right, guys, the bell's about to ring for my fourth period. I ran out of time for this video. So during fourth period, I'm going to try to make another video to finish off these notes, okay? All right, so this is going to be part 1 of the notes.